Okay, so we're doing geometric sequences. So okay, yes, this is our Tn. It's given by a times r to the power n minus 1. This is our general term. It's our general term. So we're going to investigate what's happening in this guy. So we're going to look at what's happening at T1. We're going to look at what's happening at T2. We're going to look at what's happening at T3. We're going to look at what's happening at T4. So now, if you come to this n, you substitute 1 or 2 or 3 or 4, you're going to get these terms that we're looking at. So if you substitute T1, you're going to get 1 minus 1, that's 0, r to the power 0, that's 1. So you're just going to get a. Substitute 2, you're going to get r to the power 2 minus 1, which is r to the power 1. So you're going to get ar. If you look closely, you're going to get ar squared and then ar cubed. So this suggests that T1 is equal to A. I will say this again a bit later. But also it suggests that from T1 to get the next term, you just multiply by R. Also from T3, to get T3 from T2, you multiply by R and things like that. So we're now going to look for not our difference, however, our ratio. So we're basically going to be saying AR divided by A and look at what that is. It's going to be it's going to be R. We're going to do the same thing there, and it's going to be R, and we're going to do the same thing here, and it's going to be R. So just to note, maybe not to note really, yes, this is our geometric sequence, and that's the common ratio. It's referred to as a common ratio. Yes, common ratio, general term. Cool. Now, I just wanted you guys to note a few things about what we have here. Please stop me and ask questions if you like. What is going on here? So I want you to note that this sequence, as I've said, it has a common or a constant ratio. And so yes, and that ratio is called R, and that's between terms. So what does that mean? It basically means that you multiply, or divide to get to the next term. To get to the next term. Okay, that's one thing. Also, R is greater than 1 implies that your sequence is increasing. So meaning that it's like 2, 4, 6, 8, 10, like it's going up. Whereas if your R, which is between -1 and 1, your sequence is decreasing. This is interesting. Decreasing. Okay, this is very interesting. And then note that your sequence can be written as T1, T2, T3, and so on, up to Tn rather. And I've said this before, and I said I'm going to repeat it. Note that your T1 is equal to A, and note that your ratio is given by T, n plus 1 divided by Tn. What does that mean? It basically means you divide two consecutive numbers, oh no, that's not correct, terms. And then if you look at that closely, you can write it as Tn plus 1. And also just to mention, this Tn plus 1 is a subscript, right? It's not like Tn plus 1, right? So it's like Tn plus 1, like that, is equal to Tn times R. So basically, if you are at n and you want the next term, which is Tn plus 1. So if you're at T7 and you want T8, you will just take T7 and multiply it by R. So it basically means that you times R to get the next term.
So could you please scroll down quickly for a moment, please? Thank you.
Okay, cool. And also just lastly, to note that Tn is equal to A times R to the power n minus 1. I think I'm not sure. Okay, anyway, I'll talk about that later on. The way I will do this part is a bit different. I'll ask every one of you to prepare a question in the chat, and everyone is just going to take us through the chat. And based on whether you've done the question that you meant to do, you then gonna get a mark of the chat on that. Just trying to find simple ways to get through the work. I know that's a bit unconventional.
Thank you, sir.
Okay, cool. Now let's just let's just jump into some examples. Right, jump into some examples. So I'll just say examples. So example 1, these examples are going to be similar to the examples that I've done for arithmetic, right? So I'm going to do very less and I'm going to skip certain examples on these. So the first examples is, are the following sequences geometric? Right. So if I give you A, AB, and AB squared, is this series geometric? Right. So remember, when you're trying to prove something is geometric, there are many ways you can think about it or represent it. But it boils down to you trying to calculate T2 minus T1 alone. Sorry. This is geometric, so we're not talking about the constant difference. We're trying to prove that we have a constant ratio. So we're talking about T2 divided by T1, and that would be AB divided by A, and that would be B. And also talking about T3 divided by T2, and that would be AB squared divided by AB. And that's also going to be equal to B. So it's very clear that for this case, T2 divided by T1 is equal to T3 divided by T2. So it is geometric. No, it's geometric. Why is it geometric? Because we have a constant ratio. we have a constant ratio. Now, I want to warn you guys. Sometimes when you're working these patterns, and it's bad that I don't have an example right now in front of me, is that you might find that the first three terms are both geometric and arithmetic. Therefore, sometimes to check if something is geometric or arithmetic, you might need 4 terms or something like that. I'll try to find a question like that as we go on. Okay, let's pick up another example. Right, so let's say we need to determine the just give me a second for that. Determine how many terms are in the following sequence. I just want to go back and show you something, just for you guys to benefit something from this. So you'll see that previously for arithmetic, I had this question where I said, are the following sequence arithmetic, which is what I just did now. The second problem was find the value of the first 3 terms when given the following general term. Now, I'm not doing that now for this because it doesn't matter what sequence it is, geometric or not. This skill, it's something that you cannot change. You know, this skill is something that won't go away. You know what I mean? I hope you're following. You know, you can do this for any other animal. It's like being given any function and be asked what x1, x2, x3 are. Right? Hi, Uzair.
Good evening, sir.
Are you good?
I'm good, thank you. How are you?
I'm good. Did you forget about the class?
Kind of. Yes, I did.
Oh,
So sorry for being late.
oh no, that's fine. I hope you've looked. I'll trust that you've looked at everything else. If you do need help, I will sort that out. You can mute your mic. However, if you want to ask a question, you can just ask. I'll stop what I was doing. Okay, so you will see that, guys. I didn't do that. You see also this says the one that determine the general term. Also, I'm not doing that, but I am doing the one that says determine the 11th term, and I'm combining it with how many terms are in the sequence. So I'll phrase it in such a way, right? But you're not gonna be losing, because I'm gonna say determine how many terms are in the following sequence, right? And so I'll say, and determine the 50th term, Guys, I hope I could show you what this basically means in a function, you know, but maybe no, maybe this is not a very nice illustration of how a function would look like. Okay, so let me give you the sequence. The sequence is a half, a quarter, an eighth, and it goes on to a, this could be a potential problem. Okay, solution. First of all, if you're gonna have to determine how many terms are in the sequence, right? What does that mean? So this is your first term, this is your second term, this is your third term, this is your nth term. So if you know the position of this particular term, you basically know the terms that are in the sequence, because this is the last term in the sequence, right? So which basically means that this question, the first part of this question, the first part, this part, how many terms are in the following sequence until here, before the end. That part of the question is basically asking you to determine n, right? So before you can determine n, you need to have the general form of the solution. So you need to find Tn. So this is Tn is equal to A times R to the power n minus 1. Now we know that T1 is equal to A, and therefore in this case, that would be a half. Now we need to find what R is. Now we have a half, we have a quarter, we have an eighth, and so on. I'm not gonna write the rest. So I'm gonna find what is the common ratio here. What would be a quarter divided by a half? And that question goes to Jemmy and Shana. What would be 1/8 divided by a quarter?
So 1/8 divided by a quarter is a half.
Okay, so this would
Yes.
be a half. And Jemmy, what's yours?
I think it's the same. Let me just check again. Because I put my calculator down. It's 2.
So you're saying 1/4 divided by a half, which is 1/4 times 2/1, which is 2/4, which is a half. I do want you to calculate it, because sometimes it might not. I mean, if this is geometric, then it would be, but I just want you to actively do these things. Okay, are we happy?
Yes, sir.
Okay, so now we have that our Tn is gonna be A, which is that, times R, which is that, to the power n minus 1. Now, the question that's being asked here is, we want to know what is the position. We want to know what's happening at that particular position. So we can say, surely we know that Tn is equal to 1/1024 at that position. So if we do that and say that would be equal to 1/2 times 1/2 n minus, like that, then we can solve this. Oh my good gracious me, I don't even have a calculator with me. Okay, anyway, you can see these are the same base, so you can pretty much add these. And this is 1/2, 1 plus n minus 1. So luckily for us, we have 1/2 to the power n, like that. Okay, so now please check for me, what is 2 to the power 9? Just 2 to the power 9.
It's 512.
And then 2 to the power 10?
1024.
Okay, so clearly we can write this as 2 to the power 10. Is everyone happy with that idea? So, which means that we can write this as 1/2, all raised to the power 10 is equal to 1/2, all raised to the power n. This section is gonna be a bit ugly just because of the exponential function, it's exponential equations that are involved in some uneasy algebra. So everyone can see now. Yes.
Can you please scroll up quickly?
Yes.
You see there, sir added 1 plus n minus 1. Why did sir add 1? I'm confused there.
Oh,
The
yes.
third
Because
step.
if you have a to the power n times a to the power m, you can, because you have the same base, you can just add those.
Okay, so.
So if you look closely what's happening here, this is a half raised to the power 1. But if you look closely, this base is the same as that base. So you can put that base and just add all their exponents.
Oh, thank you, sir.
Welcome. Okay, so now we should be very happy with just saying that n is equal to 10. Are we happy?
Yes, sir.
Yes,
Okay,
sir.
cool. The next question was, on that same question was, and determine the 50th term. So we have Tn, right? So we know our Tn is equal to a half. Guys, the way I write things sometimes just to simplify them, it's crazy. I would say 0.5 because it's more nice to write 0.5. But of course, no one, I don't know why people wouldn't like to write it like that. But anyway, I'll write it like that. And then I want T50. This could be very ugly soon because there's an exponential function. It grows quite very fast, quickly. Might not get this term. 50 minus 1, does anyone wants to compute that for me? Are we winning there?
It's 8.9 times 10 to the negative 16.
Sure, 8.9 times 10 to the negative 16. That's such
Negative
a very 16.
Yes, sir.
Yes, that's such a very small number. That's why I was worried that I might not get that. From physics and doing Avogadro's number, calculating the mass of an electron and things like that, you can get a sense of how small this is. Okay, anyway, it's quite very small though, right? Okay, are we happy? Is everyone following?
Yes, sir.
Now, please do this question for homework. And that is, find the first 3 terms of a geometric sequence with the 4th term equal to 28 and the 8th term equal to 448. And my video is gonna, this class is gonna cancel now. It's gonna switch off. And I will therefore carry on in the next class. So it's gonna go out and then you guys just have to come back again. With the same link, you just use the same link.